Good morning. I am Dr. SREELEKSHMY, Assistant Professor in the Department of Prosthodontics, and today we are going to discuss about inelastic impression materials. Impression can be defined as a negative likeness or copy in the reverse of a surface of an object, an imprint of the teeth, and adjacent structures for the use in dentistry. Impression material is any substance or combination of substance used for making negative reproduction or impression. Classification of impression materials. Impression materials can be broadly classified into rigid and elastics. Under rigid or inelastic impression material comes impression plaster, impression compound, zinc oxide eugenol impression pastes, and impression waxes. Under elastics comes the elastomers as well as hydrocolloids. The topic for today's discussion based on pressure exerted, the impression materials can be classified into mucostatic and mucocompressive. The topic for today's discussion is inelastic impression materials, and they are classified into impression plaster, impression compound, impression waxes, and zinc oxide eugenol impression paste. Zinc oxide eugenol impression paste. It is a mucostatic, inelastic, chemically setting impression material used for recording secondary or corrective wash impression of edentulous arches in the preparation of a complete denture. It is also known as metallic oxide paste. It is classified according to ADA specification number 16 into type 1 and type 2. Type 1 is hard set, fast setting and is of a thinner consistency, while type 2 is soft set, slow set and of a thicker consistency. It is supplied as in two tubes in the paste forms as a base paste, which is white in color, an accelerator or reactor or catalyst paste, which is red in color, as you can see in this picture. The trade names by which zinc oxide eugenol impression paste is available are DPI, AHL, CoFlow, Cavex Outline, Septodent and SS White impression paste. The uses of a zinc oxide eugenol impression material is used as a final impression for edentulous mouth in surgical dressing, bite registration, temporary filling, root canal filling, cementing medium, etc. It can be used as its additional uses. Moving on to composition. As I said earlier, it is available in two paste systems. One is base paste and one is accelerator paste. So we are moving on to the composition of accelerator paste. The main ingredient or the reactive ingredient is oil of cloves or eugenol, which is found in 12%. The major ingredient by term of volume is gum or polymerized rosin, which is in 50%, and it gives the thermoplastic property, accelerates the reaction and gives a smooth and homogeneous mix. 20% fillers like silica, kaolin, talc, etc. are added to improve the strength. Lanolin 3% acts as a plasticizer. Resinous balsam in 10% is added to improve the flow and mixing. Magnesium chloride and calcium chloride 5% is added as an accelerator, and color pigments are added as trace amounts. Moving on to the composition of base paste. Zinc oxide is the reactive ingredient, and that is the major component of the base paste, 87%. Fixed vegetable or mineral oil 13%. It acts as the paste former, the plasticizer, and it also retards the irritation of the eugenol. The setting reaction is typically an acid-base reaction and it forms a chelate. This reaction is also known as chelation. The end product we get is zinc eugenolate. Zinc oxide combines with water to give zinc hydroxide. Zinc hydroxide reacts with eugenol to give zinc eugenolate salt. The water formed is utilized in further reaction, and hence this is known as autocatalytic reaction. The setting reaction is ionic in nature, and the ionic medium is increased by the presence of certain ionizable salts which acts as an accelerator. For example, acetic acid, sodium acetate, etc. Moving on to the properties of the impression paste. The setting time. The initial setting time for both type 1 and type 2 is 3 to 6 minutes, while the final setting time for type 1 is approximately 10 minutes and for type 2 it is approximately 15 minutes. Initial setting time means it is the period from the beginning of the mixing until the material ceases to pull away or string out when its surface is touched with a metal rod of specified dimension. Final setting time is the time elapsed from the start of mixing to the instant when the penetration falls below 0.2 mm as measured with a penetrometer or similar instruments. The factors affecting setting time. Increasing setting time is seen by using a cool spatula, mixing slab, or using more zinc oxide pastes, retarders like inert oil and waxes, slower mixing, etc. A decrease in setting time or an increase in the setting reaction is seen under high temperature when there is a humid atmosphere, more eugenol paste, a drop of water, accelerators such as calcium chloride, magnesium chloride, etc. and if you have a longer and faster mixing time. The rigidity and strength. According to ADA specification number 16, at 2 hours from the start of mixing, there should be at least 7 megapascal strength. The dimensional stability. Negligible dimensional change can be seen during setting. Less than 0.1% change is seen. Biological considerations. Eugenol can cause tissue irritation and burning sensation. Manipulation. Mixing is done on a glass slab or oil impervious paper. 2 ropes of the paste of same length and width, one from each tube, that is the accelerator paste as well as the base paste, are squeezed onto the mixing slab. A flexible stainless steel spatula is used. The 2 ropes are combined with the first sweep of the spatula and mixed until a uniform color is observed. Mixing time. A mixing time of 1 minute is recommended. A paste of thick consistency can compress the tissue, whereas a thin fluid material will result in an impression that captures a negative replica of a tissue in a relaxed condition with little or no compression, as you can see in this image. Advantages. It has enough working time to do the border molding. It is easy to manipulate and not very expensive. It registers accurate surface details. It is dimensionally stable. It does not require any separating media as it does not stick to the cast. It adheres well to the dried surface of the compound, resin, shellac bases, etc. It has sufficient resistance so that the borders can be built up if the tray is slightly deficient in any area. The disadvantages are it requires a special tray for impression making. We cannot make an impression with custom tray. It adheres to the tissues. As I said earlier, the eugenol can cause a burning sensation and tissue irritation. It cannot be used for making impression of teeth and undercut areas as it is inelastic in nature, as it is rigid. It will break. Instruments are difficult to clean. Disinfection of the impression is via glutaraldehydes or iodophores. Immersion in these disinfectants is preferred. Spraying can be used for bite registration. As burning sensation is one of the most common disadvantage of eugenol, non-eugenol pastes are available. Here, the zinc oxide will react with various carboxylic acid. For example, ortho-ethoxy-benzoic acid (EBA) is a suitable substitute for eugenol. The reaction is not affected by temperature and humidity. Bactericides and medicaments, etc., can be added to limit the irritation. With this, we have come to the conclusion of today's discussion. Thank you.